Good morning, scholars. Once again, this is Mr. Lowe. This is the continuation of the 11.2 notes for analyzing and interpreting data from graphs, tables, etc. So from where we left off, we are now at a frequency table. So a frequency table lists data organized by the number of times each data value occurs. So instead of having to write 8 6 times, if it shows up 6 times, you could simply say that the number 8 happened 6 times. So if you look at this table, shoe sizes for skate rentals at a skating rink, notice that it says 6.0 with a frequency of 1. That means a shoe size of 6 showed up once. 6.5 has a frequency of 2. That means 6.5 showed up 2 times. But instead of writing it twice, they just put frequency of 2 to indicate that it showed up twice. In the case of 7, a frequency of 3 means it showed up 3 times. And you would so on and so forth navigate throughout the list. So for example 1, when they ask you how many total people are represented by the table, so you're literally adding up the frequencies. So in this case, you add the frequencies and that will get you your answer. So that's 1 plus 2 plus 3 plus 2 plus 2 plus 1 plus 2 plus 2, which should give you 15 people. So that leads you to 15 people. Example 2, write the data in the frequency table as a number list. Well, that simply means write all the data out in its expanded form. So 6 showed up once. There you go. 6.5 shows up twice. 7 shows up 3 times. 7.5 shows up twice. 8.5 shows up twice. 9 shows up once. 9.5 shows up twice. And 10.5 shows up twice. So there's your number list. Just listing the numbers that you have based off of the number of times you have it. Example 3, find the mean, median, and mode for that data set. So I guess it kind of helps that you did write everything out in that list because it will help you do 2 things. It helps you get the median pretty quickly. Remember, median is that middle number. So you're crossing off one side to the other side, back and forth, back and forth. If you do that, you're going to end up with a frequency of, with a median rather, of 7.5. So again, that's crossing off one side to the other. Mode. Mode in this case would simply be whichever number had the biggest frequency, which since that was a frequency of 3, that means that the mode is a shoe size of 7. Mean, of course, is where you do the bulk of your work, add up all the values, and then divide by the number that you had, number of values you had. So the mean, if you add all those up, that gives you 121 divided by 15. So the average shoe size was an 8.1, little over a size 8. Then lastly, what is the probability of selecting a pair of shoes whose size is smaller than 7.5? So here's your 7.5. You're looking for all those sizes that are smaller. So that's a 6, a 6.5, and a 7. So your 6s, there was 1. Your 6.5s, there was 2. Your 7.0s, there was 3. You got 6 people with shoe sizes smaller than a 7.5 out of 15. 6 out of 15. 2 over 5. That's 2 over 5. So a frequency table is just like working with any other table, except frequency means how many times it showed up. So not too much to worry about with regards to that. So our second thing that we'll look at in terms of data organization is a box and whisker plot. So a box and whisker plot is taught in 8th grade / Algebra 1, and it's simply another way to organize data that is provided to you. So with that being said, let's look at the data provided. Hours spent on homework, and the numbers are listed there. So your first thing you need to do is organize the data into numerical order from least to greatest. The examples also gives you the steps of how to actually do a box and whisker plot. So we're actually going through the actual steps of how to do this as well. Organize the data into numerical order from least to greatest. So you're taking that data, organizing it from least to greatest. If they repeat, they repeat. It is what it is. So you get 2, and then 3 shows up 3 times. A 4, a 5, a 6, 2 8s, 2 9s, a 10, 11, 12, 14. So that's all of our data values. Next thing, identify the highest and lowest values and the median of the data. So we need the highest value, lowest value, and the median. So the lowest and the highest value is pretty simple. Low value, whatever the lowest number was. High value, whatever the highest number was. The median, of course, the median is still whatever the middle number is. So go, cross off. I'm underlining in this case because I know I'm going to have to use this data later. And there's your median. So your median in this case is 8. Your median in this case is 8. So step 1, put the numbers in order. Step 2, identify the lowest value, the highest value, and the median. Step 3. So now we can get into some terminology here. Find the lower quartile of the data. Find the lower quartile of the data. To do so, find the median data value from the lowest value to the median. Do not include the median. So that means they want to know what is the middle number from the lowest value all the way to the median, but you're not going to include it. So it's just the set of numbers that I've just drawn in blue. So it's just from the numbers 2, 3, 3, 3, 4, 5, and 6. So remember, it says do not include the median. It says do not include the median in all this. So we look at those numbers and we find our middle value. Do the same thing as if we were calculating the median. There you go. So your lower quartile is equal to 3. Your lower quartile is equal to 3. So example 4, now we find the upper quartile. So it's pretty much the same steps, except now you go from the median to the highest value, but you still do not include the median. So now you go from the highest value over to the median, but remember the median is not included. The median is not included. So that gives you 8, 9, 9, 10, 11, 12, 14. So we find that middle number again. So 10 becomes your upper quartile. So 10 becomes your upper quartile. So put the data in order, find the highest, the lowest, and the median, find the lower quartile, find the upper quartile. Now you have everything that you need to make your box and whisker plot. So we're going to blow this up for just a moment just to have some room. So to make a box and whisker plot, so the first point that you would put is your low number. The next point would be your lower quartile. Next point would be your median. Next point would be your upper quartile. And the last point would be your high value. So it's only using those 5 numbers. And then the box goes on the lower quartile, the median, and the upper quartile. Hence why they call it a box and whisker plot. The whiskers are the low and high values. The box includes the other numbers. So for this data, our lowest number was 2. Our lower quartile was 3. Our median was 8. Our upper quartile was 10. And our highest value was 14. So there's our values. Connect them all with one straight line, and then we put a box around the lower quartile, the median, and the upper quartile. So there's your box and whisker plot. So we took the data, made a box and whisker plot out of it. Example 6. Write the ranges for the 4 quartiles of data, and then find the frequency of the data. So ranges is basically going from segment to segment, going about it step by step, and telling what numbers would go where. So the ranges are pretty simple. It's low value to your lower quartile to your median to your upper quartile, and finally your upper quartile to your highest value. So in your case, you simply need to identify the values that go to each part. So your lower quartile, your lower number was 2, and your lower quartile was 3. So you're literally looking for all the numbers that fall between 2 and 3. Now, any of the numbers that repeat, they do fall in line with that number. So from 2 to 3, you have 1, 2, 3, 4 numbers that would fall in that category. So your frequency equals 4. Lower quartile to median, so that's 3 all the way to 8. So 3 all the way to 8. So you don't use the 3s again, you already counted them. 4, 5, 6, 8, and 8, so that's 5. So your frequency is 5. Median upper quartile would be from 8 all the way to 10. You don't count the 8s, you already used them. 1, 2, 3. Frequency is 3. And upper quartile to your highest value, so that would be 10 to 14. You don't use any 10s because you already counted them. 11, 12, 14, that's 3 numbers. So to ask yourself, well, how do I know that I do this correctly? Add up your frequencies. Your frequencies was 4, 5, 3, and 3. That's 15 numbers. So if you look at your numbers, you should have 15 values. So if you have less than that or more than that, then you need to go back and check your work. You did something wrong. Last but not least, find the interquartile range. The interquartile range is the difference between the upper and lower quartiles. Well, then that's simple enough. So your interquartile range, or IQR for short, is equal to your upper quartile, which was 10, minus your lower quartile, which was 3. So 10 minus 3 is 7. 10 minus 3 is 7. So if you're looking at this from a application standpoint, when you're applying to colleges, most colleges will give you what is the median GPA or SAT score that they want. They'll tell you what 25% of the students, what the lower 25% did, what the upper 75th percentile did, and then they'll give you the lowest they accepted and the highest that they accepted. That's nothing more than a box and whisker plot. So as you're thinking of college admissions, just know that that's what they're doing to compile the data that they're giving you. So this takes care of a box and whisker plot. The last type of data that we're going to look at are two-way tables. So we're going to look at a two-way table. So finally, let's look at a two-way table. So a two-way table is simply an organization of data in a table, of course, that represents multiple quantities. So you just are working with multiple things at a time. But other than that, you're doing the same things that you normally would with a table. So the following two-way table represents how 100 children traveled to school one day. Now, of course, notice that there are several blanks in the table. So example 1 is to complete the table. So to complete the table, you're doing a lot of just basic adding and subtracting, and you look at the table to figure out what needs to happen. So if you start with the walk column, there are 15 boys, don't know how many girls, 37 people altogether. So to get the number of girls, 37 minus 15, which is 22. So number of girls is 22. So of course that means since the number of girls who walk are 22, 22 plus 8 plus 16 gives you that number. 22 plus 8 plus 16 leaves you with 46. If you look at the other category, 14 and 16, to get their total, you're simply adding those up. 14 plus 16 is 30. Now, to get the total people who drive a car, 37 plus 30 is 67. And since there were 100 total people, 100 minus 67 leaves you with 33. And then finally, with the car, there are 33 total people with a car. You want to figure out how many boys took the car to school. 33 minus 8, 25. So notice in filling out that table, you did nothing more than some basic adding and subtracting. So basic adding and subtracting to get that done. But now we can use it to find everything else. Example 2, find the probability of selecting a girl to interview once you get to school. So they're only finding the probability of one thing, which are girls to interview once you get to school. So you literally need to know number of girls over total students. So number of girls was 46, total students was 100, reduces to 23 over 50. Example 3, Find the probability of not selecting a student who walked to school. So not is that complementary probability. So there's two ways that you can do it. Count up all the people who did anything but walk to school. So there were 100 total students minus the 37 who walked. That means you have 63 who did not walk. So your probability is 63 out of 100. And that's it. That's all with that. Example 4. Find the probability of selecting either a girl or someone who took other transportation to school. So if you think back to the unit that we just finished on probability, that or indicates that these items are either disjoint or that there's a potential overlap. So that means we have to be very, very careful and truly pay attention to what's going on. So we're looking at the probability of a girl. We're looking at the probability of someone who took other transportation. And we're looking at the possibility if there's an overlap. Remember the girl, so the girl and the other, those probabilities we would add up. The overlap we would subtract if there's an overlap. So if there's an overlap, we'll subtract it. So let's go ahead and get to work with that. So as far as girls go, there were 46 girls. So that's 46 out of 100. In terms of other transportation, if you look in the table, there were 30 people who took other transportation. But now we need to find that overlap. So overlap being girls who took other transportation. So if we look at our table, there's our total number of girls, there's our total number of other transportation, and there's an overlap. The number of girls who took other transportation. So 16 is the overlap. So minus 16 over 100. Perform the calculation out. That gets you 60 over 100. 3/5. So again, provides a nice review of the overlapping probability. Lastly, find the probability of selecting two different students. The first is a boy who walked to school, and the second is a girl who took a car to school. So that and indicates that it's either going to be an independent or a dependent probability. So now you have to ask yourself, does doing one have a direct effect on the other? Does doing one have a direct effect on the other? So first it's and second, if you select one student, you're not going to select that student again. So now you're changing the number. Therefore, this is a dependent probability. If you pick one student, you're not going to pick that same student again. So that means you have one less person to choose from. So let's go ahead and work it out. A boy who walked to school. So we're going to have a boy who walked to school. Boy who walked to school, that's 15 out of the 100 total people. That's 15 out of the 100 total people. Times. Now you've chosen that boy. You're not going to pick that person again. So now you have 99 people. The second is a girl who took a car to school. So we go back to our table. A girl who took a car to school was 8. So that's 8 out of the 99 people that are left over. 8 out of the 99 people that are left over. So now what's left is for us to do some calculations. 15 times 8 is 120. 100 times 99, 9900. After that, we let the calculator do a little bit of work to lead us to our final answer. As I wait to get my, let's see, as I wait to get my calculator together here. So 120 over 9900 reduces to 2 over 165. So 2 over 165, and that ends up being our final probability. So, two-way table, you're filling in the table and then you're answering the basic questions that go with it. So that completes the instruction for 11.2. Everything has now been covered and will show up on that notes packet. I'll give additional instructions into Google Classroom as to when everything is due.